Okay, so let's look at this, think about it. They want us to use the table to find the rate of change. Okay, we know how to do that. But it says between at least 3 pairs. So I'm finding the slope 3 times. And then they're telling me that this function is linear. So there should be some pattern that we see between these 3 rates of change to see like what makes it linear. Why is that happening? So I'm just going to identify, I'm going to use these 2 points for my first slope, these for my second, and these for my third. You can use whatever combination you want. Like you can use the first point and the last point. It doesn't matter. I'm just using these. So for my first slope, formula is down here if you don't remember it. So again, x's are over here. Y's are over here. So y2 minus y1 is going to be 13 minus 11. And then x2 minus x1 is going to be 3 minus 2. So my first slope is 2 over 1. I'm going to do that 2 more times and see what happens. So for the second pair, I'll switch colors here. I have 17 minus 15 and 5 minus 4. Again, I have the same thing, 2 over 1. And for my last slope, I have, oops, that was y1. I have 21 minus 19 and 7 minus 6, 2 over 1. So this is definitely linear, right? I know it's a function because none of my x's repeat, and they're telling me it's linear. So they're telling me this is going to be a straight line. So what did I notice when I found the slope? I noticed that the slopes were all exactly the same. Next slide. What conclusion can you make about linear functions? So I can conclude that the rate of change, or the slope, is constant for linear functions. If it's linear, then the rate of change needs to be the same no matter which points I use. That's what we can conclude about a linear function.